Hello everyone, today I'm just going to show you how you can use this commercial software called Aqtesolv to determine parameters such as transmissivity and storativity for an aquifer. So first thing is you need to download download the software. So Aqtesolv provides a demo version of that, which is free. But if you do actually look for the full functionality, then you have to pay for the price, which is around several $100s. Okay, so once you download your software, then let's take a look at the questions that we have. So basically, we are just having like two wells. One is the pumping well, and then which is penetrating a confined aquifer with a constant flow rate. And then we have an observation well that is 60 meters away from the pumping well, and then take measurements of the drawdown. And then the question is asking us to use the Thai solution and the Cooper-Jacob approximation to determine transmissivity and storativity. So here's the data. One thing that you want to make sure is that all of your units are consistent. For example, the Q is in a unit of cubic meter per day, but the measurements are like recorded in minutes and then meters. Okay, so now let's go to Aqtesolv. So now let's go to Aqtesolv, and it seems that there are some technical issues with my recording, but probably should be fine. So the video clips are slightly like discontinued, but okay, never mind. So now let's just open Aqtesolv, and then basically you wanna so you click the thing here, and so which is new. And then you want to determine that what exactly that we are trying to do. So we are basically simulating or determining the parameters using a pumping test. So which is a pumping test wizard. So they call everything as wizard, as you can see here. And then click OK. And then you want to determine, are we going to have multi-well tests, which is you have a drawdown measuring an observation well and the water is being pumped at a pumping well, versus a single well condition, which is drawdown is measured in the pumping well only. But here we are the first conditions, and then click OK, and then next. And then here's the place that you need to tell Aqtesolv what exactly units that you're working with. So we have a length in the unit of meters, and then we have a time unit in the unit of minutes. And then there are also like you can determine your pumping rate correspondingly, like so there are some of them like a gallons per day, etc. And then hydraulic conductivity, you can also change those values as well. And then you click next. And then you can always, so suppose you are an industrial professional, then you can specify your company name. Here I'm just listing as a CE173. Then there's another thing that we need to tell Aqtesolv. So what is the aquifer saturated thickness? So in the question it doesn't really specify, but let's just assume it has a saturated thickness of 8 meters. And also, we assume an isotropic condition for the hydraulic conductivity, so which is kV divided by kH equals to 1. And then click next. So this is a place that we specify or we set up our pumping well. So the first well that comes up is usually the pumping well. So you can rename that into pumping well. And if you actually have a geological report, you know exactly where you install your pumping well, then you will have your well coordinates as well. But here I'm just leaving them as 0, 0. And then there's the well configuration. So for this question, we are working with a vertical full penetration condition. But if you do have problems understanding what exactly those means, like a partial penetration, what exactly does it mean, then you can always go to this help. And then click next. And then here's the place that we want to set up some specific numbers for the devices that we are using for pumping tests. So also like the question doesn't really specify those numbers, so I'm just going to put some numbers here. So assume an inner and an outer radius of 0.3 meters. And then click next. So this is the place that you can specify your data set. So I copy paste the data from the PDF file. And then here is the place that you need to specify your pumping rate. So here, as we can see that the data that we have is basically a constant pumping rate. So it doesn't really matter too much. However, in certain kind of conditions, your pumping rate may be different, then you will just change correspondingly. And then after you do this pasting, you can see, the first row doesn't really have the data, which doesn't really matter too much. And then you click next. And then here's the place that you tell Aqtesolv where exactly your observation well locates. So it's from the question is 60 meters away. So we just put a 60 there and then click next and then next for this as well. And then we leave this the same as what we did before for the pump well. And then this is a place that you you tell Aqtesolv what is my draw down measurement. So I convert the units as well, and then you copy and you paste. And then you click next. So this is all the things that we need. And you can see that the error log identifies error detecting your data set. Choose a view when you see the check errors indicator on the status bar. And as you can see, the fonts that are being highlighted as right shows that no errors detected in the data set, which means that we're all good to go to determine our data. So for example, we can displace the time and displacement. So this is also related this, so we can see that the time is in a log scale, and then which is usually that how you can do that by hand as well. And then this is the data that is being showed up here. And the next thing is that we want to feed some solutions. So first, we can it's basically you click this match and then solution, automatic solution doesn't matter too much. And then you have to activate the solutions. So solutions that's currently inactive. And then here we are working with the confined aquifer. So you click confined aquifer and you can choose a Thai solution or a different kind of solution. They're all different kind of solution that is being available. And if you're interested into knowing what exactly what solution represent what equations, you can always like check those things on the left, as you can see. So here I'm just going to use the first one, which is a Thai solution. I mean, and actually you can, and then because we don't really have a recovery data here as well, and then click OK. So now you can see there's a line showing up, which is basically the best fit based on this Thai solution. And then we can determine our parameters. So we have a transmissivity around 0.9 meters square per minute, and then storativity of 9.54 times 10 to the negative 5. So you want to make sure that all of those values make sense to you. So for example, we are working with a confined aquifer, then there will be a specific range of the storativity. So if you actually have a storativity equals to 20, it means that something is wrong. Okay, so this is the first fit of a Thai solution, a specific Thai solution. There are other solutions that is available. So for example, I mean, if you look at this data, it's kind of like approximately like a linear shape. So you can definitely fit Cooper-Jacob solution. So you go to match solutions and you change to Cooper-Jacob, you click OK. And then you can see now this is my new solution. And then you have a parameter T transmissivity around 0.92 meters square per minute, and then storativity of 9.54 times 10 to the negative 5. So you can see they're approximately the same for both conditions. And then there's actually one good thing to do is that if you actually like go on here, like where my click locates, you can see there's a match visual. So you basically you can draw different kind of lines here. And then each of the line is going to give you different measurements. So for example, sometimes you may wanna have specific conditions to match like some specific data. So this is occasionally like why sometimes this visual fit will work. So here, like this is another fit that I just randomly do that has a transmissivity of 0.9 and then a storativity of 9.743. Okay, so because we are using a demo version, so the save doesn't really work here. But if you want to save your file, I would highly recommend that you go to the computer labs on the third floor, fifth floor. They do have a version of the Aqtesolv that you actually can save to your local file. Okay, so this is basically everything that I have for the Aqtesolv tutorial, which is really straightforward. And if you do have any questions towarding Aqtesolv, feel free to come to my office hours. And then because due to the shutdown of the campus due to PG&E, so I'm now able to do a troubleshooting of module mules. So if you do want me to take a look at your module mules that you run into any problems, feel free to come to office hours. All right, thank you. Hope you enjoy this tutorial. Hopefully this is going to be helpful for you.